Welcome everybody to this topic. We will today study about curve resistance, right? So, what is curve resistance? It is the resistance that is provided to the vehicle when it is moving on a horizontal curve. When the vehicle is a rear wheel drive and front wheels are turned to the left side, the total traction force is reduced by value of cos alpha, and the total curve resistance that we get is T minus T cos alpha, right? So that is what we are explaining. The automobiles are steered by turning front wheels, but rear wheels do not turn, and which causes the front wheel to be resistant to movement, and the traction force that is pulling the vehicle forward is reduced by T cos alpha. When a vehicle is driven by rear wheels during traversing on a horizontal curve, the direction of rotation of a rear and front wheel is different. So that is why tractive force T is provided to the rear wheel in the direction normal to its axis. As the vehicle is on a horizontal curve, the tractive force available to the front wheel is T cos alpha, where alpha is the angle at which the turn is made. The loss of tractive force on horizontal curve is known as curve resistance. So it is represented by T minus T cos alpha. The discussion of this will be continued further when we will try to calculate the grade compensation that we need to provide on a horizontal curve, right? So after this, we'll have a look at vertical alignment. What is vertical alignment? Whenever the road that we are traversing is moving from a topography where the gradient or longitudinal gradient of the road is changing very frequently, we need to provide vertical curves. So that is what we are studying about. The natural ground may have vertical undulations at certain points that affects the vertical alignment of the highway, and that's why we need to provide the vertical curve. In general, the highways are lined along the natural topography of the area while keeping in view the drainage considerations, but some cases it is so that the requirement arises for the vertical curve. Right? Vertical alignment, it affects the following points. Acceleration and deceleration of a vehicle is affected by the vertical curve, right? Operational cost of a vehicle is reduced or increased as the vertical curve is provided. The reason being, the vehicle moving downhill will be having low cost of operation, and the vehicle moving uphill will be having high cost of operation. Next is speed. The speed of the vehicle reduces while going uphill. The side distance requirement also increases because of the vehicle, as it moves on the vertical curve, the side distance requirement increases. Next is comfort requirements while driving. There are comfort requirements while we are designing the transition curve as well. So such requirements are arising. Such requirements also arise while we are designing the vertical curve. So vertical alignment consists of two things. First one is gradient, and the second one is vertical curve, right? These are the two things that we will study, right? Next, let's study about gradient. What is gradient? It is defined as a change in elevation height of road along the longitudinal direction of the road. It is represented as, it may be represented as 1 in x, it may be represented as x%, which is given as x in 100 or x upon 100. This is a way to represent it. Tan alpha is another way to represent it, where if we look at this diagram, the alpha is the angle that is made by the road. If this is the road that we are talking about, let me increase the this is the road we are talking about, right? And this is the horizontal alignment, and this is the vertical movement of the road. So as if I try to explain it in simple terms, as soon as we move 1 kilometer in horizontal direction, what is the change in the elevation of the top surface of the road. If it is 50 centimeter, then we can say that the gradient would be 50 centimeter per 1 kilometer. This needs to be converted into centimeters, so that would be 3 centimeters upon 1000 meters, or 10,000, 1 lakh centimeters if I am not wrong. So this would be 1 upon 2000. This would be represented as 1 in 2000, or it can be represented as, this has to be converted into percent. So okay, it can also be represented in percent as how much a value it is decreasing per 100 movement, and alpha, to get the value of alpha, tan alpha can be represented as this is also equal to tan alpha. So which implies alpha is equal to so tan inverse then alpha will be equal to 0.0286, right? So it is so. Next, we'll have a look at what is the angle which measures the change in direction. Now this is a note that we have provided. The angle which measures the change in the direction of the intersection at two grades is called as deviation angle. It is actually the angle that is equal to sum of this. If we have two pavements that are meeting on different gradients, this is N1 and this is N2. The two angles that the pavement is making are alpha 1 and alpha 2. Then N is the deviation angle that is given as alpha 1 plus alpha 2. It can also be given as, if this is positive and this is negative, so alpha 1 minus alpha 2, that will also come out to be alpha 1 plus alpha 2, right? Next is, there are different types of gradient. What type of gradients could be there? Ruling gradient can be one of it, limiting gradient is there, exceptional gradient is there, and minimum gradient is there. So we'll talk about them one by one. Ruling gradient is the design gradient. It is the gradient with which the designer designs the vertical profile of a road, right? It is the ruling gradient. It is the gradient that is maximum times used over a road. Gradients up to ruling gradient are adopted as normal course in a design. However, flatter gradient may be preferred whenever possible, and it is always preferred that the vertical gradient is avoided. The reason for that is operational cost of the vehicle increases, as well as the comfort requirement is there. So that is why it is avoided that the vertical gradient may be provided. In some cases, due to topographical requirement, there is a requirement that it needs to be provided, then it is unavoidable, then we provide the ruling gradient. Limiting gradient is, there are such situations where the topography demands that gradient may be increased from ruling gradient. The gradient can be extended up to limiting gradient in such cases. It is provided for a limited length only, and it is not provided beyond that. The limited length is not as such defined in the IRC, but for exceptional gradient it is defined. In case of situations where gradient steeper than limited gradient needs to be provided and is unavoidable, the exceptional gradient may be provided. It is provided only for a length of 100 meters, and beyond that it is not provided. A steeper or flatter curve has to be provided after that, because the reason for that is the traction capacity of a vehicle reduces after traveling a distance of 100 meters. So that is that. Minimum gradient. The minimum gradient required to ensure proper drainage along longitudinal direction of a road is known as minimum gradient. It is the gradient that we cannot provide a gradient below this. The reason for that is there needs to be provided drains along the longitudinal direction of the road, and that is why these are provided. As per IRC, for concrete drains the minimum gradient is 1 in 500, and for earthen drains it is 1 by 200. If there is permeable soil, the minimum slope that needs to be provided is 1 by 100, when penetration of water can be observed in the soil. So as per the IRC, following are the gradients as provided by IRC. Ruling gradient is 1 in 30, 1 in 20, 1 in 15 for plain and ruling, limiting and exceptional. Then mountainous region is where RL is less than or equal to 300 meter but greater than 1000 meter. Then the ruling gradient is 1 in 20, 1 in 16.7, 1 in 14.3. Steep terrain is when RL is greater than 3000 meter, then ruling gradient is 1 in 16.7, 1 in 14.3 and 1 in 12.5. It is so because since above 300 meter oxygen available is less and optimum combustion of the engine is not possible. So the optimum power is not generated, and hence the vehicle requires greater or steeper gradient. Next is grade compensation of a horizontal curve. What is grade compensation? Whenever a vehicle is driving on a horizontal curve as well as it is driving on a vertical curve or vertical steeper gradient it is traversing on, then there is less traction is available as discussed previously. Curve resistance is there and less traction is available for the vehicle to traverse the road. In that cases, it is preferred that the compensation is provided to the vertical gradient, and that compensation is measured as this formula. But let's first understand what it is. On horizontal curve, due to turning angle of vehicle and rear wheel drive, curve resistance is there, that is equal to T minus T cos alpha, and hence resistance is more due to the horizontal as well as longitudinal gradient, or we can say this has to be changed to vertical gradient, right? Therefore total resistance is equal to grade as well as curve. Hence when sharp horizontal curve is introduced on a road which already has a maximum permissible is ruling gradient, the reduction in gradient is to be carried out. This reduction is known as grade compensation, which is equal to 30 plus R divided by R, where R is equal to radius in meters. The maximum value of grade compensation is limited to 75 divided by R as per IRC. Therefore, grade compensation is basically minimum value of these two values, 30 plus R upon R and 75 plus divided by R. Grade compensation is not required for roads having gradients less than 4%. So this is a problem that I have mentioned. I'll request you all to kindly have a look at it and kindly share the answers in the comment box. What is this? What will be the compensated gradient when ruling gradient of 6% is provided on a curve of radius 60 meter and when ruling gradient of 5% is provided on a curve of radius 60 meters. So that's all from my side. Kindly try to solve this and comment the answer. If you are not able to solve the problem, kindly share that also in the comment. I'll put a solution for the numerical. So that's all from my side. Kindly like, comment and subscribe to the channel. Thank you. Thank you and have a good day.